Welcome to this explainer. Okay, let's jump right into something that absolutely flipped the tech landscape on its head recently, the unprecedented June 2026 AI outages. Today, we're going to unpack the exact engineering playbook you need to keep your stack online when the ground literally shifts beneath your feet. Because honestly, if you were building an AI product recently, you know exactly how fragile the ecosystem can be.
Just look at this timeline. It's kind of wild when you map it out. In June 2026, the US government enacted these sudden export controls, and man, the effects were immediate. We're talking within just 90 minutes of a commerce directive, Anthropic's highly anticipated Fable 5 went completely dark worldwide. Poof, gone. And over the next 3 weeks, OpenAI's GPT 5.6, instead of getting that massive general release everyone expected, was shipped to only about 20 government-vetted partners. Suddenly, the top frontier models just vanished for almost everyone. If your product was standardized on either of these, you learned a brutal lesson. Model access is simply no longer something you have total control over.
So what actually caused this massive global shutdown? It wasn't just a standard policy tweak. It all boils down to a specific and heavily enforced concept called a deemed export. Basically, this rule treats the act of serving a model to a foreign national as a restricted export even if that person is sitting right next to you in your own office. This structurally excluded mixed nationality teams, EU entities, and offshore contractors literally overnight. This is exactly why the June directive forced a global shutdown rather than just a, US-only pause. It wasn't paranoia from the labs, it was a plain, strict regime of the regulations that caught so many engineering teams completely off guard.
So here's our roadmap for today. We're going to map out exactly how we move from this new, unpredictable reality to a bulletproof, decoupled architecture. We'll hit the new threat model, the golden rule of architecture, the resiliency playbook used by the survivors, and finally, the real-world data and trade-offs. All right, let's start with part one, the new threat model. We're dealing with a totally new category of risk here, and it's fundamentally different from the standard API outages we've been navigating for the last decade. I mean, for years, provider risk just meant your API was down for maybe 2 hours, right? You coded a simple retry loop, got a coffee, and everything was fine. That is a solved problem. Today, the fundamental lesson is clear, and this quote perfectly nails it. The more of your stack you actually own, the less anyone else's decision can hurt you. We're now dealing with indefinite, government-ordered removals of specific models. There's no service-level agreement to fall back on, no ETA for a fix, and absolutely no appeals process. It's just a completely different paradigm.
Moving right along to Section 2, let's talk about the golden rule.
If you want to survive this new landscape, there is one absolutely non-negotiable architectural pivot that every single engineering team has to make right now. Changing your primary model must be a simple config file tweak that a tired, heavily caffeinated engineer can safely execute at 2 a.m. under intense pressure. It cannot be a 2-week hostage situation disguised as an engineering sprint. Seriously, if swapping your model requires rewriting core code, you don't actually have an independent stack, you have a hostage situation with a vendor and a government that you didn't choose. So everything we discuss from here on out is about making sure the answer to which model am I using remains nothing more than a simple string in a config file.
Okay, Section 3, the resiliency playbook. Let's crack open the exact step-by-step playbook used by the organizations that actually survived the blackouts without breaking a sweat. Step 1 is absolutely crucial. Map your dependencies before the disaster strikes. You simply cannot hot swap what you haven't inventoried. The teams that sailed through June, they all had one thing in common, a brutally honest, up-to-date map of every single model, provider, cloud, and integration they relied on. They classified their workloads by how critical they were and honestly assessed their real downtime tolerance. This map tells you exactly where your single points of failure are hiding, and believe me, it is the one document you're going to be incredibly grateful for the next time an unexpected directive lands on a Saturday morning.
Once you've got that map, your biggest, most load-bearing move is dropping in an LLM Gateway. To achieve that config-level swap we just talked about, you absolutely must put a model abstraction layer in front of everything, exposing just one OpenAPI-compatible endpoint to your code. Now, when choosing your gateway, there are some honest trade-offs. If you want total control, LiteLLM is your open-source go-to. If you need production guardrails, like PII reduction for regulated work, Portkey is excellent. For unifying public providers with your own self-hosted models inside a virtual private cloud, TrueFoundry is a great pick. And while OpenRouter offers amazing zero-ops managed deployment, keep in mind it's US-hosted, which makes it a tricky fit if you have EU user data with strict residency obligations. But for almost every team, the right move is to grab one of these gateways. Don't roll your own unless you have some highly unusual latency constraints. Right behind that shiny new gateway, you need to establish a cascading safety net. You define your primary frontier API, a secondary alternative API, and finally, a last resort tier. But here is the real kicker. You have to actually practice failing over to them. A fallback plan that you've never actually routed live traffic to isn't a strategy. It's just a hope. You've got to run these drills on a normal, boring Tuesday so that flipping the switch becomes sheer muscle memory on the really bad days.
So let's talk about that last resort tier. This is your untouchable rung. This tier absolutely must be an open-weight model deployed on infrastructure you actually own. The good news? Modern open-weight models have closed a massive amount of the performance gap. Models like Qwen 3 Coder are hitting nearly 70% on SW eBench verified, while Kimi K2 scores incredibly well on agent decoding. But, and this is a big but, license over label is the whole ballgame here. You need genuinely permissive terms like Apache 2.0 or MIT, and you must serve it locally using engines like VLLM or SGLang. Doing this completely sidesteps those nasty deemed export traps we discussed earlier. It's the perfect untouchable answer, especially for European and non-US builders.
Now, having a shiny new fallback model is completely useless if you don't actually trust its outputs, right? The main reason teams couldn't swap quickly in June wasn't just technical plumbing. Actually, scratch that. It was mostly a lack of trust. To make a model swap take an afternoon rather than a fortnight, your prompts must be abstracted away from specific model quirks. You need a portable evaluation suite that scores any new candidate on your actual real-world tasks. That eval harness is the difference between saying, well, we could switch and we did switch before lunch. Also, never ever just pull the latest version. Pin explicit model hashes so things don't break unexpectedly. And finally, keep your RAG stores and data logs in region. These new covered frontier models now come with mandatory 30-day data retention policies, which might severely conflict with your prior zero retention agreements. You really have to own your data path.
Finally, let's hit Section 4, Data and Trade-offs. Look, let's be real, none of this resilience is entirely free. Pretending it's a perfectly seamless swap is a failure mode all on its own. If you look at Swebench Pro, there's a pretty stark gap between the closed frontier models, which sit around 80%, and open-weight models, hovering nearer to 62%. We have to acknowledge that relying purely on an open-weight floor currently comes with a capability ceiling for your absolute hardest reasoning tasks. They just trail on the broadest knowledge constraints. So think of the open tier as your highly resilient floor to keep the lights on during a crisis, not necessarily your daily driver for the most complex computations. Plus, adding that abstraction gateway adds a tiny bit of latency, usually only single-digit milliseconds, but still, and self-hosting definitely requires some real operational burden.
But hey, there's a massive upside here that makes this architecture an incredibly easy sell to your management team. Self-hosting your steady, high-utilization workloads acts as a huge cost saver. To put it into perspective, roughly 10 million output tokens a month on a frontier-priced API might run you about $500. But the equivalent self-hosted inference, that lands nearer to $50 to $150 in amortized GPU and power costs. It essentially pays for your resiliency insurance. It turns out that resilience and cost efficiency are built using the exact same architecture. Pretty cool, right? So here's the bottom line. You cannot control the gate. Washington is going to keep making decisions about which frontier models ship, and both leading labs are actively pushing to make that review process permanent. The gate isn't going away anytime soon. But by implementing this decoupled architecture, by building that abstraction layer and keeping a tier you own outright, you transform what used to be an existential, company-ending crisis into a completely boring everyday routing rule. The frontier will absolutely keep getting gated. The only question you have to answer today is, will your product go down with it?